Hello everyone. Welcome to our final project presentation for ACR 502. So we are team 2 and today we will be presenting our custom programming language CrazzyLang. So my name is Dhyey Patel.
Hi, my name is Arpit.
Hello everyone, my name is Anmol.
Hi everyone, my name is Sujan.
Alright, so in this video we will walk through our presentation slides, explain the language design, then demonstrate the full execution of CrazzyLang using simple program. So let me take you to the presentation first. Alright, so let's start with the narration that the CrazzyLang is a lightweight, beginner-friendly programming language that we designed and implemented from scratch. Our goal was to build a complete language pipeline, including lexer, parser, AST builder, and the runtime interpreter, while keeping the syntax uh, simple, readable, and expressive. If we talk about the motivation, then to talk about motivation, then our motivation for this project was to understand the process behind the real programming language, how source code is being converted to tokens, how grammar guiding parsing, how abstract syntax tree are formed, and finally how runtime environment execute the code. We wanted to create a language that feels intuitive to beginners while demonstrating the full compiler work. So let me talk about some design philosophy. So our guiding principle were readability, simplicity, modularity, consistency, and extensibility. We chose human-friendly keywords such as say, when, na, loop to make language approachable. We also maintain a clean separation between the front-end parser and the back-end runtime so that each part remains easy to remain and extend. Let's talk about the
Language
language feature.
features.
So
Yeah,
Arpit will continue from here.
yeah. So for the language features, CrazyLang supports integers, booleans, and strings. It includes arithmetic, relational, logical, and ternary expressions. We provide a statement for variable declaration, assignment, printing, conditional, and looping as well. All program use the .crazy extensions, so it runs smoothly. When it comes to architecture, our principle begins with the lexer, which tokenize the input. Next, the parser checks the grammar rules and creates the parse tree. The ATS builder simplifies the tree into a clean node structure. Finally, the Java runtime interpreter works the AST and executes each statement. Okay. Next is grammar overview. So we used Antler R4, Antler 4 for grammar implementation. The grammar includes a rule for statements, loop, conditionals, and expressions. Expressions follow a clear precedence hierarchy, and we removed left recursion for clean parsing. Next is
Token
token
specification.
specification, which will be taken by Anmol.
Hello everyone. So speaking about token specification, so our language includes the keywords, identifiers, numerical literals, string literals, and Boolean values. Operators like plus, minus, double equals to, and logical operators are tokenized by the lexer. This clean token stream ensures the parser receives fully categorized inputs. Speaking about example program, this sample program demonstrates conditionals and a loop. The when, else when, and na structure, like if else. The loop until statement repeats execution until condition becomes true. The output shown matches the expected behavior. And after that, speaking about the execution flow diagram. So this diagram summarizes the entire workflow, the given one. The crazy file goes through the lexer, then the parser, then the AST builder, and finally the runtime interpreter. Each stage processes the code in a structured, predictable way. This was it for the diagram. Speaking about challenges and solutions, Sujan will continue. Thank you.
Yeah, coming to challenges and solution, throughout the development, we faced several challenges, including operator precedence, left recursion, and managing the runtime environment. We address this by structuring our Grammarly carefully and implementing a clean AST visitor pattern and designing a scoped variable environment. These decisions helped maintain a clarity and correctness across the entire execution pipeline. And coming to runtime intervals, our runtime uses a tree walking interpreter model. The interpreter evaluates the AST nodes recursively and executes statements in lexical order. The environment is stored as a map that maintains a variable values and supports reassignment. Control flow structure like loops condition are evaluated based on expression results, ensuring flexible and predictable execution. And coming to AST node types, we defined a compact set of AST node types representing every part of a language, such as assignments, print statements, conditionals, loop, and expression. This design keeps the interpreter predictable and easy to debug. Having a clean and consistent AST structure also makes future enhancement more manageable. And coming to testing and debugging, we tested the language using a multiple .crazy files covering arithmetic operations, logical expression, nested controls, loops, and string handlings. Handlers parse tree viewer and our own runtime logging helped us diagnose issues during the development. Throughout testing, we achieved a stable behavior across all supported constructs. Coming to the future scope and conclusion, in the future, we hope to add addition, better error reporting, more data types, and potentially a bytecode system to optimize execution. To conclude, a dot crazy language demonstrates a complete and functional language pipeline with the intuitive syntax, a modular compiler structure, and a reliable runtime. This project has given us a deep insight into the how project languages are designed and executed. So next will be taken on by they for the execution. Like
Hi. So let's begin with the project. So first of all, we compile our, first of all, let's create everything. So first of all, we'll just build everything and just compile so that we can see that everything works fine. So as you can see, the uh, Lexa and parser is generating what we want, and the program is compiling successfully without any issues. So let in the data doc, there are multiple .crazy files which we have used. For example, let's say it's a control while statement file. It's a file to check the working of NA. If we check about the arithmetic thing, then we can check with this file. For the ternary operators, we can go with this file. So let's run a single file. Let's say we are running the control if statement file. It is of the first file. So in which we can print like for I in loop 1 to 5, we want to print I. So let's see what will be the output. Oops. Yeah, so equal 5. So we'll get output. Let's check for another program. Let's say we want to check about the if else loop, like test if else. All right, so we get that x is equal to 5, and we just put a condition that when x is greater than 3, we have to say greater, otherwise we have to say smaller. So we are getting the output as greater, which is correct. Let's put x is equal less than 3. We should get an output level. Oops. All right, we will get a output smaller. So similarly, we can just run we can run each and every file to get the output. All right, so that I think that completes our demonstration. Thank you for watching our final presentation and demo for the CrazzyLang. I hope you like it, and it's a great teamwork. Yeah,
Thank you. Thank you so much, Dhyey.
thank you so much,
thank you
Dev.
so much,
Thank you
everyone.
so
Yeah.
much,
Thank
Dave.
you.
Thank you, everyone.